We'll continue with weight, power, and energy and laws of motion practice questions. The first one here. A boy and a sled weighing 300 newtons slide down an ice covered frictionless hill AB. At the bottom of the hill, there is an ice free patch BC. The horizontal surface brings the sled to a stop within a distance of 27 meters. What is the coefficient of friction between the sled contact runners and the horizontal patch? So at this point it comes to rest, the velocity is 0, but what will be the velocity here just after it comes from the top? So at this point, of course, there is no velocity, but because of elevation there is potential energy, and that potential energy is all going to be converted to kinetic energy at the bottom. Potential energy mgh is going to be equal to kinetic energy half mv squared. The masses cancel out because they are equal. So GEA is 9.8. The height at A is 10. That will be half velocity at B squared. So I'll multiply this two in the denominator by this term to remain with V. So V is going to be 2 multiplied by 9.8 multiplied by 10. Because this was V squared, I'll square root here to remain with V. And that is going to give us 14 meters per second. That's the velocity at B. So using the equation of motion, let's find the acceleration for it to move from the point B to the point C. So that would be 2a, the distance it travels is 27, and that would be equal to final velocity is going to be 0. The initial velocity, that is the velocity at B, is 14, so it's square that. So therefore the acceleration is just going to be negative 14 squared, and then we divide by 2 multiplied by 27, these two values, because we want to remain with A alone. So therefore A is going to be negative 14 squared divided by 2 multiplied by 27. That is going to give us a negative 3.6296 meters per second squared. This negative won't be squared because it's not part of the portion that is being squared. Now that we found the acceleration, we want a coefficient of friction. The net force acting on the sled in the x, there's no forward force, but there's a friction force that is going to make it to go to stopping. The net force is given by mass multiplied by the acceleration. That will be equal to negative friction force given by coefficient of kinetic friction times normal force, and normal force on the level ground is mg. The masses again get to cancel out. The acceleration is negative 3.6296. That will be equal to negative mu k multiplied by g, which is 9.8. The negatives are going to cancel out. Therefore mu k is going to be 3.6296 divided by 9.8. Is going to be 0.370. We have seen that we haven't even used the weight. Of course, when something is under the influence of gravity falling, the velocity doesn't even depend on the weight of something. It only depends on the elevation from the point where it is dropping. So that is why even knowing the weight doesn't affect our calculation. A block of mass 2 kg is released from rest at point A on a track that is a quadrant of a circle of radius 1 meter. It slides down the track and reaches point B with a speed of 4 meters per second. So at this point it has got 4 meters per second speed. From point B it slides on a level surface or a distance of 3 meters to reach point C where it comes to rest. So here the velocity is 0. So the first question, what is the coefficient of sliding friction on the horizontal surface? From this point to this point, that's the horizontal surface. What's the coefficient of sliding friction? Just as we did in the previous question, we'll first get the acceleration. V squared minus u squared is equal to 2as. So that will be 2a, the distance which it travels is 3. Final velocity is 0, but the initial is 4 squared. So therefore the acceleration is going to be negative 4 squared is 16 divided by 2 times v, that is a 6. So the acceleration is going to be negative 16 divided by 6, which is negative 2.67 meters per second squared. Now we go again to find the coefficient of sliding friction. The net forces acting on this object, there is no forward force, but there is a friction force opposing motion. That is why it goes to a stop. Net force is mass times acceleration, that will be negative mu k times normal force, which is mg. The masses again get to cancel out. We can as well use the mass 2 kg, which is given, but there is no need. So the acceleration is negative 2.67. That is going to be equal to negative mu k times normal times g, which is 9.8. The negatives will cancel out. Therefore mu k is going to give us 2.67 divided by 9.8, which is 0.272. Coefficient of friction is unitless, so there's no need of putting a unit. Second question, how much work is done against friction as the body moves along the arc AB? So how much work is done against friction? How much work is done against friction? Well, at the top point there is potential energy. This thing is not moving at point A, but as it gets to slide, the potential energy is going to be converted to kinetic energy. And also some work done by what? Against friction. If we want, we can just find the total energy on top. Let's find the total energy on top. That is only potential energy at the top. So potential energy, that is mgh. The mass is 2, gravity is 9.8. The height, that is just the radius of the what? Of the semicircle, which is 1. So that is 2 multiplied by 9.8, which is going to give us 19.6 joules. So this is the energy at the top. Let's find the energy at the bottom. And we have got kinetic energy here because something is moving. That is half mv squared. And that is going to be half. The mass is 2. The velocity at that point is 4 squared. What will we get? 4 squared. This 2 and this 2 just cancels. 4 squared is a 16 joules. So this is the only kinetic energy present at the bottom. Where has the other energy gone? The difference between the energy on top and the energy down, where has it gone? That energy was used in overcoming friction. So that is why we can see there is a reduction in energy. And to find the work done by friction, that is why we just get to put potential energy is 19.6, and that will be equal to kinetic energy, which is 16, plus work done. Okay. A work done against friction. So the work done against friction, that is 19.6 minus 16, that is a 3.6 joules. That is it for this problem. Or we would have said final energy minus initial energy. That would have shown a negative sign, meaning for friction. Find the acceleration of the 5 kg crate. So here we've been given a problem. You have got this one which is going down. Also this one will be going in this direction. But notice this one has got a higher mass than this one. So obviously in this scenario, the direction of motion will be like this. So even this one is going to be pulled in that direction. So in this case, we are taking that the motion here, the crate is, the incline is frictionless. So there is a force going in this direction by the reason that this mass is on an incline, that is called Fg. So let's first look at this mass. What's the net force acting on it? The net force acting in the y is equal to what is going down, that is mg, and then we have got a tension in the rope that is preventing motion, and that is mass times acceleration, that is equal to mg minus t. So the mass, that is 10 kg, multiplied by the acceleration, that will be 10 multiplied by 9.8 and then minus t. So that will be 10a is equal to 98 minus t. And then now coming to this one, the net force acting on it, that is in the x direction. The force going in the direction of the acceleration, that is the tension, minus the force going against the direction of the acceleration, that is Fg. We need to be very careful with this, because if we get to swap them, we might find something that is different. We need to take the direction of motion, and in this case we've taken the direction of motion as this direction. So everything that is going in this direction is going to be positive, everything in this direction is going to be negative. Net force is mass times acceleration, and that will be equal to tension minus Fg. Fg is always given by mg sine theta. So the mass there is 5 kg multiplied by the acceleration, that will be equal to tension minus mass again is 5, g is 9.8, sine the angle of the incline is 40. So this is going to be tension minus 5 multiplied by 9.8 multiplied by sin 40. That is going to give us a 31.49659. I can take this term the other side to make t this update the formula. So that will be positive 31.49659, then plus 5a, that is going to be equal to tension. So where there is tension here, I'm going to substitute that value. What is that going to give us? So that is going to be 10a is equal to 98 minus, where there is tension, 31.49659, and then plus 5a. We'll distribute the negative, that will be 10a is equal to 98 minus 31.49659, and then minus 5a. I'll take this 5a, the other side becomes positive, so it will be 15a is equal to, so we have got 98 minus 31.49, which will give us 66.5034. So to find the acceleration, divide both sides by 15, and that is going to be 4.43 meters per second squared. So that is going to be the acceleration of the block, that is 5 kg. That is also the same acceleration for this one. But if we take the direction of motion, if we take the planes, the positive x-axis and the negative x-axis like that, then this acceleration is going to be negative for block A, and it's going to be also negative for this block Y, because it is going in the negative Y direction. But if we take just motion like this as positive, then that is fine. The second question, find the tension in the string. Now, since we've already found the acceleration, to find the tension, we've seen the formula is here, or we can just use this one. Any of them is going to be fine. So let me use this. 10 multiplied by the acceleration is 4.43. That is going to be 98 minus tension. So I'll take t the other side, and then I'll take this term the other side. So that will be tension is equal to 18 minus, when we multiply here, it will be 43.3. Okay, like that. Actually, this is a 98, not 18. So tension is going to be 98 minus 43.3. That is going to give us a 53.66 newtons. So that is it. Well, for this one, that is a projectile motion practice question. It is also solved. You can just get to check out the video projectile motion practice question.